Lost in time, ancient DNA identifies mysterious people who lived in the Americas, unrelated to natives, then vanished. For centuries, we believed we had the story of the Americas figured out. We knew where people came from. We knew how they spread across 2 continents. We had the map. It was neat, it was clean, it was complete. We were wrong. Hidden 6,000 years deep in the Colombian highlands, ancient DNA has revealed something that shouldn't exist. A population of people who don't belong anywhere on our genetic map. They lived here, they thrived here, and then they vanished completely. No descendants, no trace, just bones in the ground, and a question that rewrites everything we thought we knew. Who were they? And more importantly, how many other ghost populations are we missing? Let me take you back to what we thought we knew. If you opened any history textbook for the past 50 years, the story was simple, beautiful, even. During the last ice age, when sea levels dropped, a land bridge appeared between Siberia and Alaska. We call it Beringia. It was a grassy highway lined with mammoths and bison, and sometime around 15,000 years ago, or maybe earlier, we're still debating, the first humans crossed it. These pioneers carried with them the genetic seeds of everyone who would inhabit North and South America. As the ice retreated, they moved south. They split into 2 main branches, the northern Native American lineage and the southern Native American lineage. These 2 family trees, according to everything we've been taught, explain virtually every indigenous civilization from the Arctic to Patagonia. 1 migration, 2 branches, continuous flow, simple, elegant, textbook perfect. Except there was a massive problem with this beautiful narrative, and nobody wanted to admit it. Colombia had become the most important genetic blind spot in the world. Think about it. Colombia is the gateway. It's the narrow funnel where everyone moving from North to South America had to pass. If you wanted to reach the Amazon, the Andes, the Pacific coast, you had to go through Colombia first. This wasn't just a stepping stone. This was the point where the entire peopling of South America happened. Yet when geneticists looked at their maps, they had ancient DNA from Chile. They had it from Peru. They had sequences from all over South America. But Colombia, nearly nothing. It was like having a perfect family photo album of everyone in your lineage, except for the person who started everything. Scientists knew this gap was a catastrophe. Without actual DNA from ancient Colombians, they were basically guessing. And guesses, no matter how logical, aren't science. They couldn't write the true history of the Americas until they cracked this one region. For years, they tried. The problem was the climate. Too wet, too warm. Ancient DNA degrades easily. Bones crumble. The genetic material vanishes. Scientists needed somewhere cold, somewhere dry, somewhere that acted like a natural freezer. Then they thought of the highlands. The Bogotá Altiplano sits nearly 2 miles up in the Andes. It's cold, it's stable. It's the kind of place where ancient organic material can survive for thousands of years almost perfectly preserved. An international research team, experts from the University of Tübingen and Colombia's National University, decided to search there. They spent years carefully excavating 5 archaeological sites across the highland area. What they pulled from the ground were fragments of bone and teeth, 21 individuals, spanning 6,000 years of history. Getting the DNA out was like pulling a crystal-clear message from a million crackling radio signals. The ancient genetic material was fragile, degraded, contaminated. But when the team finally succeeded, they achieved something historic. They had the first ancient human genomes ever published from Colombia. The blind spot was finally illuminated. What they found, however, shouldn't have existed. When they ran the genetic sequences through their databases, comparing them against hundreds of ancient and modern populations from across North and South America, something impossible appeared. The oldest samples, dating to around 6,000 years ago, didn't match anything. The researchers checked their work. Was it contamination? Was the dating wrong? Number. The evidence was undeniable. These people, a group of hunter-gatherers who lived at a site called Checua, had a genetic signature that simply did not belong to the established American family tree. They weren't distant cousins of known Native American groups. They weren't a branch of the southern lineage that was supposed to dominate the region. They were entirely separate, a basal lineage, a completely distinct branch that had diverged early in the peopling of South America. Scientists called them the ghost lineage. The map wasn't incomplete. It was wrong. And at the crossroads of the continent, an entire population had been living in the dark. Here's where the story becomes tragic. The Chekwa were small, maybe a few hundred people living in the high-altitude cold of the Altiplano, at 2,600 meters above sea level. They hunted deer, they fished, they gathered wild tubers and fruits, and for thousands of years they stayed isolated, kept separate from other populations by geography, by chance, or by choice. This isolation had a profound consequence. Their DNA became pure, homogeneous. When you have a small population that doesn't interbreed with outsiders for 4,000 years, genetic diversity shrinks. Their unique genetic signature became preserved in crystalline clarity, the very thing that makes them such an incredible discovery today. But here's the cruel irony. The thing that made them special also made them fragile. A population that pure, that small, that isolated, it's a ticking clock. Their specialized genetics were perfectly optimized for survival in their isolated highland world. But they lacked something crucial: genetic diversity, the immune defenses built through contact with different populations, the flexibility to adapt when their world changed. We know they faced health challenges. Physical remains show signs of jaw abscesses from infections. They lived a difficult life in a difficult place. And then, around 2,000 years ago, their unique genetic signature vanishes entirely, completely. No gradual fade, no intermarriage with newcomers, a clean cutoff, a complete population replacement with zero genetic overlap. The Chekwa lineage was erased. The truth is, we don't know for certain, and that's what makes this so haunting. One theory: climate change. The warm period around 6,000 years ago could have disrupted their food sources. A population already stressed by altitude and isolation couldn't adapt. Another theory: disease, and this one is chilling. A small, isolated population lacks broad immune defenses. As new groups began moving through the Colombian corridor, people connected to populations in Panama, they brought diseases the Chekwa had never encountered. Pathogens that might have been harmless to the diverse newcomers could have devastated an immunologically naive population. This is a recurring, tragic pattern in human history. Or perhaps it was gradual replacement. New migrants arrived in force, more numerous, better connected to broader networks. Over centuries, the Chekwa population was absorbed or displaced, not through warfare, but through the sheer weight of demographic momentum. We may never know which factor dominated. The genetic evidence is crystal clear on one thing, though. They were gone by 2,000 years ago, and what replaced them was different entirely. When the Chekwa vanished, the vacuum didn't last long. A new population arrived. They brought pottery, the Herrera ceramic complex. They brought agriculture. They brought a completely different way of life. And when scientists sequenced their genomes, the result was shocking. These newcomers showed strong genetic links to populations from the Isthmus of Panama. They were likely Chibchan speakers, a language family still spoken in parts of Colombia and Panama today. This reframes everything. For generations, we thought about human migration as a one-way flow, people moving south from North America. But the DNA reveals something more complex. Yes, there was a major migration wave coming down from the north around 2,000 years ago. But there was also a previous isolated population that had to be completely replaced first. The newcomers thrived where the Chekwa had failed. They became the direct genetic ancestors of powerful, organized groups like the Miscas, a civilization that flourished in the Colombian highlands right up until the Spanish arrived. Success, it seems, requires connection, diversity, a web of relationships beyond your isolated valley. Here's what keeps scientists awake at night. If one entire, genetically distinct lineage could vanish without a trace, erased from the gene pool despite living in the center of the continent for 4,000 years, how many other ghost populations are we missing? We only found the Chekwa because they lived in a place that preserved their bones. The high altitude, the cold, the dry conditions. It created a time capsule. But what about the Amazon? What about the Pacific coast? What about all the lowlands and jungles where bones crumble to dust within centuries? There could be dozens of lost lineages buried beneath the earth, unique populations with their own stories, their own adaptations, their own cultures, all erased from the genetic record. We may never know they existed. This discovery proves that the early Americas weren't a simple story of continuous populations slowly evolving into modern indigenous groups. It was turbulent, dynamic, filled with isolated success stories and total genetic dead ends, populations that thrived for millennia only to vanish completely. The Checua people remind us that our map of the first Americans is still being drawn. Their story forces us to stop looking for one continuous migration and start actively hunting for hidden, lost lineages in overlooked areas. The DNA from the Checua bones speaks volumes about diversity, about disappearance, about the fragility of small, isolated groups facing the relentless pressure of connected, dynamic populations. They were here, they adapted, they survived for 4,000 years, and then, by forces we may never fully understand, they were gone. But they're not forgotten, not anymore. What do you think happened to them? Could disease have been the culprit, or was it something else entirely? Drop your theories in the comments below. I'd love to hear what you think about this ghost lineage. If you found this story as fascinating as I did, please like, subscribe, and share this video. Subscribe to History Diary for more stories where science reveals the secrets of the past. Because history isn't finished, it's just waiting to be unearthed and rewritten.